Finding the Laplace transform of a piecewise function. So recall, if f of t is a step function, u of t minus tau, times some function g of t, then the Laplace transform of f of t is e to the negative tau times s times the Laplace transform of g of t plus tau. Okay. Also recall that if we have a piecewise function, so if we have a piecewise defined function, then we can take the Laplace transform by first rewriting the piecewise function using step functions. So if we have a piecewise defined function, then we can rewrite the function using step functions. Essentially, for each new step, we subtract off our previous stage and add on the new stage. So for each new step, we subtract off the previous result, or we subtract off the previous defining function and add on the new one. So the previous stage and to add on the new. Once we reach that point where we've rewritten our piecewise function using step functions, then we can apply that fact that the Laplace transform of u of t minus tau times g of t is that e to the negative tau s times the Laplace transform of g shifted. So let's go ahead and find the Laplace transform of f of t, which is equal to 2t plus 5 for t less than 6. It's equal to t squared minus 2 for 6 less than or equal to t less than 12, and it's equal to 3 for t greater than or equal to 12. So the first thing we want to do is rewrite f of t with step functions. So we initially are 2t plus 5, that's everything to the left of 6. So we know that f of t should start off simply with 2t plus 5, and then we'll add on something else. So this remainder that we need to add is to correct for t greater than or equal to 6. So we'll do our next correction from 6 to 12. So we know that f of t should be equal to 2t plus 5. Then we will start our step function at 6. So we have u of t minus 6. And then we will multiply by, we need to subtract off the 2t plus 5 that we already have. And then add in our desired t squared minus 2. Then again, we have to add on an additional component, and that is to do the correction for t greater than or equal to 12. So at this point, we have f of t is equal to 2t plus 5 plus u of t minus 6 times, we'd have a t squared minus 2t minus 7 would be what was left inside. And then our last stage, we're correcting at 12. So we would need to do u of t minus 12. And then the previous piece of the piecewise function was t squared minus 2. So that's what our function totals to at this moment. So we will need to subtract off t squared minus 2. Sorry, not 2t, just t squared minus 2. And then we need to add on what we are now trying to land on, which is 3. So we will add 3. Oops. So again, just a reminder that u of t minus 6 and u of t minus 12 are both 0 up to 6. So up to 6, the function is just 2t plus 5. Between 6 and 12, that first function is 1 and the second function is 0. And so we'd have 2t plus 5 plus t squared minus 2t minus 7, which would land us straight on t squared minus 2. And then beyond 12, both of our step functions equal 1. So adding it all up, we would have 2t plus 5 plus t squared minus 2t minus 7, which is t squared minus 2. And then we would have minus t squared minus 2. That all goes to 0. And we're just left with the 3 that we wanted. So this is our final end result. Of course, we could rewrite this as 2t plus 5 plus u of t minus 6 times t squared minus 2t minus 7. I apologize, my screen didn't update. We have our u of t minus 6 times t squared minus 2t minus 7. And then that last piece will become plus u of t minus 12 times, we would have negative t squared. And then plus 2 plus 3 would be plus 5. So this was our first stage. Now we can go ahead and take the Laplace transform. So now let's take the Laplace transform. So the Laplace transform of f of t should be equal to the Laplace transform of 2t plus 5 plus the Laplace transform of u of t minus 6 times t squared minus 2t minus 7 plus the Laplace transform of u of t minus 12 times negative t squared plus 5. So let's go ahead and do each of these Laplace transforms separately. So let's focus first on the Laplace transform of 2t plus 5. So this one is straightforward. Laplace transform of 2t plus 5 is just 2 times the Laplace transform of t plus 5 times the Laplace transform of 1. We know the Laplace transform of t is 1 over s squared. So we have, this is t to the first power. So we would have 2 times, we'd have 1 factorial, where s to the 1 plus 1 is technically our rule for powers of t. And then we'd have plus 5 times Laplace transform of 1 is just 1 over s. So we are looking at 2 over s squared plus 5 over s is the Laplace transform of that first component. Now let's focus on the Laplace transform of our second component. So we have the Laplace transform of u of t minus 6 times t squared minus 2t minus 7. So we have times t squared minus 2t minus 7. we're going to go ahead and call that t squared minus 2t minus 7 g of t. And so we know that this Laplace transform should be equal to, our tau here is 6. So we should have e to the negative 6s times the Laplace transform of g of t plus 6. So now we need to figure out what is g of t plus 6. So g of t plus 6, g of blank is equal to blank squared minus 2 times blank minus 7. So g of t plus 6 should be t plus 6 squared minus 2 times t plus 6 minus 7. So we have g of t plus 6. We would have t squared. Then we would have plus 12t minus 2t is plus 10t. Then we'd have plus 36 minus 12 is 24 minus 7 is plus 17. So g of t plus 6 is t squared plus 10t plus 17. So our Laplace transform of u of t minus 6 times t squared minus 2t minus 7 should be equal to e to the negative 6s times the Laplace transform of t squared plus 10t plus 17. Now from here we can work our way through. This is e to the negative 6s times the Laplace transform of t squared plus 10 times the Laplace transform of t plus 17 times the Laplace transform of 1. Oops. That last one should be a square bracket at the very end there. Now we have e to the negative 6s. T squared, we would have 2 factorial, sorry, we would have 2 factorial up top, and then we would have s to the 2 plus 1 down below, or s cubed. Then we'd have plus 10 times 1 factorial over s to the 1 plus 1, and then plus 17 times the 1 over s. All of those fractions are being multiplied by that e to the negative 6s, not e to the negative s. So e to the negative 6s times 2 factorial over s to the 2 plus 1, plus 10 times 1 factorial over s to the 1 plus 1, plus 17 times 1 over s. I just realized my screen did not update. Simplifying this just briefly, we have e to the negative 6s multiplying 2 over s cubed plus 10 over s squared plus 17 over s. Finally, let's take our last piece of that Laplace transform. We needed to do the Laplace transform of u of t minus 12 times negative t squared plus 5. So taking the Laplace transform of u of t minus 12 multiplied by, I already forgot what it was, negative t squared plus 5. If we take that negative t squared plus 5 to be our g of t here, then this Laplace transform should be e to the negative 12s. Our tau here is 12 times the Laplace transform of g of t plus 12. So we need to know g of t plus 12. So we have g of t plus 12, g of any blank should be equal to a negative that blank squared plus 5. So we have a negative, then t plus 12 inside parentheses squared, and then plus 5. So g of t plus 12, we would have a negative t squared. Then we would have minus 24t. Then we would have minus 144 plus 5 becomes minus 139. So this is our g of t plus 12. So we have the Laplace transform of u of t minus 12 times negative t squared plus 5. This is equal to e to the negative 12s times the Laplace transform of negative t squared minus 24t minus 139. So we are looking at e to the negative 12s times the negative Laplace transform of t squared minus 24 times the Laplace transform of t minus 139 times the Laplace transform of 1. We have e to the negative 12s, and we have times negative Laplace transform of t squared. We again would do 2 factorial over s to the 2 plus 1. And we have minus 24 times 1 factorial over s to the 1 plus 1. And then minus 139 times 1 over s. So this Laplace transform becomes e to the negative 12s times, we would have negative 2 over s cubed minus 24 over s squared minus 139 over s. So putting this all together, we wind up getting that, so putting this all together, we have the Laplace transform of f of t is equal to, our first piece was 2 over s squared plus 5 over s. So we have 2 over s squared plus 5 over s. Then we have plus e to the negative 6s times, we wound up with e to the negative 6s times 2 over s cubed plus 10 over s squared plus 17 over s. So times 2 over s cubed plus 10 over s squared plus 17 over s. And then our last place, we should have a plus e to the negative 12s times, we had negative 2 over s cubed minus 24 over s squared minus 139 over s. So again, I broke down the Laplace transform into pieces, sort of very pieced down here. As you get more comfortable with Laplace transform, you can probably skip some of the broken down steps, but any chunk of the piecewise component, any step function times, I would separate out and work on those individually, just so that you keep track of which should be multiplied by which exponential. But again, this is how we can go about taking the Laplace transform of a piecewise defined function.